Okay, everyone. So welcome to the Innovation Showcase session. So we have today invited three companies to share their innovation stories around semiconductor sustainability. So this is not intended as a company or startup pitch session. Instead, we wanted to share some of the companies that are already working on semiconductor sustainability related technologies and really highlight some of the unique challenges and opportunity in this space. So with that, first we have Craig Beckman. Craig is the CEO of Aquamembranes, and he will tell us a little bit about how their water membrane innovations help the semiconductor industry to be more sustainable. Let's welcome Craig.
Thanks a lot, John. Appreciate the invite, and thanks to everybody for their interest in sustainability and especially water sustainability. That's really our heart and passion at Aquamembranes. We're based in Albuquerque, New Mexico, and focusing on reverse osmosis technology. But I thought it'd be interesting to talk a little bit first about the why. I've been in startups now for quite some time, and it's always one of my first questions in meeting with other entrepreneurs of the business of, I'm interested in what you're doing, but I'm also interested in why. And so at Aquamembranes, we talk about we're creating space. And it's a little play on words, you'll get in a minute, but we like to think that we're creating space for improvement of our employees, our investors, our customers, and the globe that we all need to share. So again, this forum is super passionate to me personally in being able to talk about sustainability. So we'll talk a little bit about water purification in general, and then we'll dive down into how the semiconductor industry uses water, how they treat water, how they recycle water, and some of the challenges to do that sustainably. So water treatment's been around for a long, long time. The technologies used in our industry are actually relatively recent, starting with ion exchange technologies, where we first started exchanging sodium for other hardness related ions, then moved that into more ion exchange technologies. And then the membrane technology really was a game changer, developed in the 1960s, primarily for seawater desalination first, to turn seawater into drinking water, but then quickly advanced into industrial applications. And we'll really focus today mostly on reverse osmosis, even though the industry uses a lot of technologies in water and waste treatment. So RO technology is used in a lot of applications, a lot of industries besides semiconductor. As you'd expect, power generation and pharmaceutical production. You might be surprised a lot of the home units now actually use reverse osmosis technology. Some of the earlier speakers talked about those forever chemicals like PFAS, or we're all very familiar with the lead issues that have been problematic throughout the US. RO technology in your home is a great solution for that. Another application you might not be as familiar with would be orange juice treatment. To actually ship orange juice cost effectively, sustainably, it's actually much more cost effective to take the water out of it. So the same technology, the same membrane elements used in a UPW fab might actually be used to concentrate orange juice in Brazil to ship it to Florida. If we look specifically at the semiconductor industry, really, I would say that the RO is the backbone of the water treatment process in UPW, whether we're looking at the makeup plant or the polishing plant. It's a critical step, and one of these steps that has been in innovation over the years, lowering the energy and improving its performance, but we're getting pretty close to a theoretical limit of how much we can improve it or how much energy is required in the element. It is still one of the higher energy consumption areas on this chart, and also especially one of the higher waste users. So if you actually dive down into that to another level, this is not the semiconductor industry by themselves. Instead, if we step back and look at the entire industry, the entire world and their use of membrane technologies, about 180 billion gallons or 160 billion gallons a day is used around the world for some of those various applications. And so that's super beneficial, but it does come at a pretty high waste. If we look at the CO2 and the emissions associated with the energy needed for the process, it's 1.8 million tons every day. 30 million of these units are disposed in landfills every year just because they wear out. And probably most disturbing for me in the industry is the amount of water we have to put down the drain or we waste. Andres just talked about this, of the metric of looking at how much raw water we use compared to how many semiconductors we produce. And the ratio is not good globally. We dump 30 billion gallons of waste for every 160 billion gallons that we make as good product. One of the reasons for this is just the way the element is constructed. We won't get into a lot of detail with the time we have today, but you could think of a reverse osmosis membrane as an envelope rolled up on a center tube. You can actually see it pictured here in the chart. But in order to push water on the surface of that envelope to get water through it and purify it, you have to have some kind of a flow mechanism or a feed channel. And this is really the problem that Aquamembranes is going after. The innovation that we're starting in is, how do we make that more efficient? How do we make a feed channel or a flow channel through the membrane element that uses less energy and uses less water? And one of the reasons we use a lot of energy in the industry is to push the water through there. And we try and create turbulence to prevent the scaling and fouling you can see right in this element. But even with the very high energy that's used in the industry today, we still have relatively limited life on the elements. Depending on where they're used in the semiconductor fab, if they're used on a waste recycle or maybe even a concentrate, further concentration ZLD application, they might only last a year or two. The UPW elements that have much more pretreatment have much longer life, but still it's 5, 6, 7 years, and they need to be disposed of, usually because they don't perform enough or produce enough output. And this mesh feed spacer is really often the problem. So that's the innovation that we're working on. Aquamembranes has come up with a 3D printing technology that allows us to take that mesh material out of the membrane wrap, and instead we can actually print a surface, a number of dots, lines, forms right on the membrane surface. You can see it pictured here. And the technology to actually print and cure things is actually very common. In fact, it's used a lot in your industry in different steps of the production. But printing and curing something on a membrane surface that is very delicate and has to maintain certain salt rejection and throughput has really been the challenge. And so Aquamembranes has been at this for quite some time. And one of the interesting developments of coming into the microelectronics space, that's actually one of the most difficult areas to do this application. Another application we're working on right now, for example, is residential water. Well, residential water doesn't have nearly the requirement of purity on the water that this industry does. And so that's one of those challenges of, as an entrepreneur, we have to look at the different industries and how difficult and what kind of a return we could get. The VC team before lunch was talking a little bit about that too, of, it's not maybe the first industry lots of entrepreneurs go into, and we probably are included in that. So if we look at some of the values we can create with that new printed spacer technology, this is actually looking at the wasted energy associated with the process. Reverse osmosis technology, as the name implies, is overcoming the process of osmosis. So there's actually an osmotic pressure we always need to overcome just to push the water through and get pure water out of the salt water. So this graph is actually looking at the wasted energy in the process, not the total energy. Total energy, depending on where you're at, is maybe 5 to 20%. But really what we're targeting is the availability that's left over. What can we take out of the process? And this is that wasted energy pushing the water through the system. And we've shown in both field and lab studies with many applications that could actually be up to a 55% decrease simply by taking out that mesh material that the elements have been constructed with really since they were developed, and instead replacing it with a customized pattern. How this might look for a UPW fab, depending on your application, we tried to project, based on some of our current data, savings per year. This is megawatt hours per year for some different applications, graphed over different flow rates. Some of the speakers earlier were talking about the total energy use in this industry. So this doesn't represent a lot. If you looked at a fab of Intel or Micron or TSMC, these savings are still going to be in the low single digits of how much energy they use, or maybe not even crack 1%. But also, as we've been talking all day, semiconductor manufacturing is incredibly complex. And our recommendation would be to look at it literally step by step, process by process, and then even drill in another level. We're not looking at the entire UPW plant. We're only looking at the membrane step. And in the membrane step, we're only looking at the membrane element construction. We're not looking at energy savings of energy recovery devices or electrical efficiencies like pumps or motors. We really dove right down into one specific item and said, we can save you some energy here. Another interesting value proposition that we can bring, some of the earlier speakers have talked about this as a metric, the 3x30 from Micron, for example, is one of their metrics was 30% reduction in footprint to get the same output. And our technology does enable this, at least in the water treatment space. And you can see it pictured here. The printed product is on the right and the mesh product being on the left. That traditional mesh spacer has to be a certain thickness to get the water pushed through it because it's an overlapping strand material. You can think of our technology almost as peeling off one of those strands, and we're only on half of the side. So therefore, we can actually reduce that gap by half, which almost doubles the amount of area we can put in the same size system. So what this allows a fab to do, especially in today's extreme demand conditions we find ourselves in, it has the potential to decrease the footprint required to produce the water, both the utility water, the feed water to the UPW, some of the waste concentration systems we were just talking about. All of those could have a smaller footprint if we get better packing density into each membrane element that's actually doing the separation. And you can see here, a visual difference of those two. And now how that might look for an existing fab, I suspect most fabs around the world are actually even more crowded than this picture. As you've expanded continuously and more production has to come out of more and more places, or fewer and fewer places, space becomes a significant premium. And so that idea of increasing output from the UPW system 10, 20, maybe even 25%, only with a membrane and pump change could be very valuable for customers. So those are really the innovations and some of the values that we're bringing to the industry, with diving down into the construction of the filter and seeing, again, how could that be made differently? And then with my remaining time, I wanted to talk a little bit about lessons that we've learned here at Aquamembranes. I've done some sustainability development in water technology in past roles as well. So these are drawn on both selling new technology into sustainability applications, as well as breaking into maybe new markets. As I said, Aquamembranes, some of our earlier investors and earlier pushes were in the residential and home-based business. And just recently, in the last 6-12 months, we've gotten more pulled into the semiconductor technology development and trialing. So I guess my first lesson is, investment is certainly accelerating. This is kind of a no-brainer. But I've been in the startup world of water for 29 years now, and I would say the last 2 years is by far and away, more than the first 27 years combined. And water is a part of that, and water efficiency. We often hear the water energy nexus talked about, and even some of the earlier speakers talked about this. It's really hard to disconnect the two. Because whenever you use water, you're likely using energy to move it, to clean it up. And often the goals are counterproductive, that if you need to get more water recovery, it'll actually cost you energy. And so we see this kind of optimization point in there of there's got to be a balance between energy use and water usage, because if you focus on just one or the other, it'll probably have a negative effect on the other. Investors, consumers are starting to reward good behavior. We're seeing this a lot more in consumer products, that consumers will actually look at the product, investigate the product. What is the water footprint of this product? What is its carbon footprint? How much water was used to make this product, especially in products that are liquid, whether it's a packaged soft drink or others. More and more people now are looking at how much water did you use to make that 1 liter of product? Is it 1.1, 1.4, and how can you make that better? So I think we're going to see a trend where consumers and investors are driving innovation and adoption. Information is easier to get than ever before. It's very easy to find out different companies' sustainability footprint. A number of the speakers earlier today were talking through their sustainability metrics and how they do it. Most big companies now post something online, and so consumers will find it easily and quickly, and probably more than they've ever found in the past. My next lesson is aim high. This has been some of the challenges that have been talked about just as of late of, the semiconductor industry and chip production by its nature is energy intensive, chemical intensive, and water intensive. And many of the chemicals that are used, just because of the applications we have to do, are very difficult to treat after they've been used. But that doesn't mean we shouldn't try. And that's my encouragement to a lot of entrepreneurs or even VC investors that are out there. If it looks like it's maybe, literally a moonshot or comparable to it, somebody's got to do it, because this industry and all industries need to get better with the resources we have. Sustainability crosses industries. What I mean by this is if you are an investor or an entrepreneur, it's very helpful to actually have sustainability to jump from one industry to the other. And that's been something for us. We got pulled into the space by Micron that did an investment in us earlier this year. And they found us through a marketing event. We were pitching for an accelerator for some other segments and contacted us and, are moving quickly now to do trialing, which is really great for us because of the cachet and reputation that you get in the semiconductor space, because everybody knows it's a difficult space to get qualified in. It actually makes our job as a startup easier to go into food and beverage or power generation or oil and gas if the semiconductor industry is using it first, even though the semiconductor industry definitely has higher hills to climb and more stringent specifications. And lastly, just weight keeps the flywheel spinning. I love this form. I wish we would do more of these. The more we can get entrepreneurs, partners, corporate venture teams talking together, sharing lessons, sharing learnings, the more virtuous that cycle goes and the faster it spins. So I just want to thank John and the whole forum for the time today, and happy to take some questions.
Perfect. All right. Thank you very much, Craig. For those of you who don't know, as Craig mentioned, they recently successfully raised financing from Micron Ventures. And so I guess a quick question for you, you kind of mentioned very briefly how you got connected with Micron. Maybe just, you're one of the many startup companies that I can think of that are not necessarily in the semiconductor space, that are, doing your own sustainability related technology development, maybe some other market verticals. Maybe just elaborate a little bit how you got introduced into the semiconductor space, and having been working in this area for 6 to 9 months, what are some of the experience you can share with other startup companies who may also wanted to look at semiconductor as a potential market vertical to enter into?
Sure. Yeah. So I mentioned we were doing an accelerator. I would encourage startup entrepreneurs out there, startups, even small companies, to continue to participate in marketing events. Most of it's online these days, but continue to look for any opportunity you can to talk about your technology, because you never know what connection is going to happen. And so perhaps somebody is in the power generation field, but they came from the microelectronics industry, or they came from a different industry, and they still have colleagues in that other industry, and they take your technology or recommend somebody goes back over there. So even if you have a technology that's focused specifically on municipal wastewater cleanup and nutrient cleanup of nitrogen, but that has other applications in other industries, from food processing to potentially even semiconductors. And so it is a constant battle for startups to where to focus your energy. And we talk a lot about you have to have a beachhead. So you can't do everything for everybody, but you do want to be looking strategically. And I think the semiconductor industry offers some of those benefits, as I said, that because it is an industry that is growing, is quite profitable, and has challenging problems to solve. If you can solve a problem for that industry, adoption in other industries makes it easier, because you have the credibility of, yes, I've been operating in a semiconductor fab for 6 months, a coal generation power plant or a oil and gas refinery is going to look at that and say, oh, yeah, if you're doing that wastewater recovery over there, that gives me more comfort to run a trial or potentially even move forward. It's actually another reason I'm a big fan of corporate venture. We have investors, both traditional venture capitalists as well as corporate venture partners. And we really like working with the corporate venture partners because they can bring the money, get the good return, assuming our success, but also they use the product. And very often for startups and entrepreneurs, that is our biggest hurdle. How do we get meaningful customers using the product to take that risk? Just like we were talking about recycling materials, somebody's going to have to take a small risk in order to adopt some of these new technologies.
Wonderful. Thank you. Thank you very much.
Sure.
So next up is Oliver Wyrsch. He's from Inficon. So Inficon is not a startup company, and they're actually already serving the semiconductor industry with their advanced sensors and energy auditing and energy efficiency solutions. So let's welcome Oliver to tell us more about Inficon's sustainability solutions and innovation strategies. Unmute.
Thank you very much, John, for having me. I'm really excited to be part of this forum. I've watched many of the presentations today, and it's fantastic to see the momentum in sustainability that there are all around this industry now. So as you said, Inficon itself is a little bit a grown-up startup, if you want to call it that way. We are listed in Zurich, about 500 million revenue, 1,200 employees, and have a footprint around the globe, a lot in semi-heavy areas, even though we are also working with other industries. Our focus really from the origins was on gas analysis. We are the global leader in that, but a strong innovator and also using a lot of other technologies. But with a strong focus now with semiconductor that just has grown so much over the recent years. Below you see a couple of our products. There's a large variety there in different measurement instruments of different types. In general, Inficon takes a very comprehensive view on sustainability. We believe this integrates well into the environment, of course, but also social governance and into our products that, again, are used for sustainability efforts of companies. And we see a clear benefit of combining the two. On the right side, an example from our annual report where we show how we built up our remote service using HoloLenses, which in the end adding customer value for a quick response and very useful in certain cases as opposed to travel. And with this, of course, we're reducing also carbon footprint at the same time. So we have numerous of these examples that we have every day in different touch points across this initiative that we're running. And it has been around for some time, our sustainability approach, but really, much like I heard just now, it has been taking off very recently quite a bit more and becomes a big topic, which is fantastic to see. Really. So if you look at the products that Inficon Intelligent Sensor Solutions has, you see they are in numerous markets, but with 5 focus markets that actually converge in certain areas, which is quite interesting, which is actually happened recently. So there's mobility, e-mobility, healthcare, there's renewable energy, industry 4.0 and smart manufacturing with a strong focus on semiconductor, and then environmental monitoring, which of course is also very much connected. If I remember the earlier presentation of Andreas that talked about how the fab works and how the environment monitoring gets more and more important. For the fab itself, if you look at that, we obviously have worked a long time in semiconductor and have a lot of established products there. While this is, of course, products that have been around, some of them, but because the industry is moving so fast, we are also moving fast and try to innovate all the time on the products that we have and add new variants and new technologies. The key applications we work for in the fab is the management of the process chambers itself and its supporting systems, making it more efficient and safer, and in the end, reducing the resources that are used. Leak detection is a big topic in many shapes or forms. Then smart power management across the fab, but especially also in the sub-fab recently, such as for pumps for longer lifetime, and also there minimizing the consumption. And in the end as well, actually coming from another field and more moving into the semiconductor space is our continuous and mobile monitoring of water and gas. Which is really products that we have used in many other industries and now become pretty dominant also in this space. So just to show you what kind of complex stuff you can do, I'm not going to walk you through this. On the left side, you see one of our latest innovation. It's a mass spec combi sensor with a QCM on it, with a quartz crystal microbalance sensor. It's called Transpector Apex. It has all technology that we are a leader in for a long time around mass spec, but you also see this fancy purple coating, which is an innovation we have for cleanliness, and then the combination of a sensor with this quartz crystal that is a sensor that we are leading globally as well, and the combination of it as well. On the right side, you see how we monitor a process chamber. This is an example from a plasma etch CVD clean, and you see the two steps there of the clean, the faster and the slower one, and the endpoint that we detect. So by optimizing these processes, you can reduce the use of process gas and obviously also all kind of waste and scrap. And that's our approach to it. If you do a smart monitoring and a smart management of these chambers, you can gain a lot. In the end, that's how you can go and really proactively manage your resources better. How we did this, typically when we develop variants, it's a lot of rapid prototyping. We are present in most fabs and work directly together with the customer, really immersed and working on the latest issues and problems and applications they have, and then rapidly prototype new variants of this or new sensor technologies to solve problems that arise. So more on how we innovate. We are a bit bigger, right? With 1,200 people, it's harder to act as a startup. I have a past also in startups, and what you actually need to do is keep this startup spirit and keep small multifunctional teams that have rapid innovation cycles and are very close to the customer and very immersed, like I described earlier, in the fabs, working with process engineers and finding solutions. You see on the left side, it's also about fun and collaboration. There's a couple of pictures of different prototyping and knowledge sharing sessions. And on the right side is our approach, which we believe is unique, that works for our size of a company, but still has a rapid prototyping and an innovation cycle. We combine agile on a large scale with lean startup, and then the design thinking for analyzing the customer problem. Here's an example of a collaboration. It's a lot of collaboration ongoing. So this is maybe far away, you could say, from a semi-fab, but in the end, with the collaboration that we do with NASA, we can actually test out these harsh mass spec products in a total different harsh environment, which then again lets us learn for the semiconductor fab, or vice versa. We learned a lot in the fab for this application. What we do here specifically is, as you might know, we're trying to go to Mars, not Inficon specifically, NASA and all the collaborators. And for that, you need a permanent moon base. And to find a good spot for a permanent moon base, you need to find water. And our sensor is the sensor that is on these 4 missions that's flying to moon to find that spot and the water specifically. So this is what this is. It needs to be ruggedized, obviously, to go and be able to fly with a rocket to the moon. and there's a couple of other specific features that it needs. So on the left side, you see a few of our people are on the NASA roster as well, with this relatively tight collaboration we do. And we have more collaborations all across. We're trying to really work with the leading edge collaborators across the globe in our sensor technologies. To bring it to a close, Inficon in general has a strong footprint and is continuously innovating around smart fab. And this is about sensors, new sensor technologies, and also about the right data evaluation, data analytics, and software. And we combine this all together and have a clear focus on the semiconductor industry, and also a clear priority on making the fabs of the future sustainable and also smart. Thank you. And now I'm ready for a couple of questions, John.
All right, sorry about that. So very exciting stuff, helping NASA finding water on Mars. That's impressive. So Oliver, I guess, as I mentioned, Inficon is a sort of an existing supplier into the semiconductor space. I'm curious, what are you hearing from your customers, with regard to sustainability? Are you getting these kind of requests to push you towards, supplying components that are more efficient, and also pushing you to improve your operation to be more sustainable?
Yeah, very good question, John. Actually, I would say it's the same thing as Craig before. I think the last few years, it really has ramped up significantly on different ends. So certainly on the product end, that our products are more used for sustainability goals or achieving the goals. So we have specific products for that now. It's variants or even new products. But also in terms of collaboration, I think the whole industry is now really trying to make a leap forward. And we, as basically all players, I believe, in the semiconductor industry, have to have strong plans to really move the needle now on sustainability. Whereas maybe 5 years ago, it was more hypothetical in certain areas, or maybe not such a high priority. It really became now a top topic. So it's not only about quality and delivery times or innovation of a product or cost at what it may be. It's also about the sustainability. It's a fixed component now, which is really very, very good to see.
Sounds like what you're saying is sustainability is not just a differentiator in your competition, but also almost becoming a must-have when you want to work with semiconductors.
I believe it is both, right? It's certainly when you are ahead of the game, it's a differentiator, but it clearly becomes a must-have now, which is good to see again. So that's where you make the big transformation.
Yeah. So maybe also, Oliver, we have some more time. Just tell us a little bit about some specific innovations or promising technologies that Inficon is looking for, or you guys are working on, that are specifically related to the energy efficiency and also process, just overall smart manufacturing.
Yeah, certainly this is a big topic, and I think there's quite a list of ideas we have there. And the most recent one that I mentioned earlier is certainly important. The one you see here in the background, this is this Transpector Apex, a very smart sensor that can optimize processes. And there's a number of sensors that will manage process gas better. And there's a lot going on in the subfab. So we really now use quite some sensors that we have used in other industries in applications in the subfab, which are continuously expanding. So we're actually not fully clear on all the requirements we have there. So we're very interested to find out more and engage in the conversations. And we have a couple of very good collaborations going already, where a couple of these smart management, energy consumption products are already in use and sold. So this has really picked up, I would say, specifically, I think 2 years ago. We really saw an uptick trend that you actually see a material part of our revenue coming from this type of products.
Fantastic. Can you elaborate a little bit this particular part of the product?
The power management.
Mm-hmm.
Yeah, this is this has a connection to the analytics of sensors and how you make a smart strategy of when you run, for instance, or make it simple, how you run your pumps in the subfab, right? How much idle time you can get out of it, how much power management or power reduction you can get out of it is what this software together with the sensor does.
Excellent. So it's a combination of sensors and also software solution that goes with it.
Yeah, I mean, all of our sensors have quite some software integrated. No sensor can be a dump, if you want to call it like that. All of the sensors these days need to be smart, right? There's an enormous amount of data that you get with the sensors, and you need to evaluate it. You need to analyze it. You take it apart, and you extract the specific features that you need for it. And that's what we use when we set up, for instance, also this power management.
Perfect. All right. So with that, I think we can maybe move on to the next speaker. So now you have heard innovations around water technology and also smart manufacturing, energy efficiency technologies through sensors and etc. So the next speaker, we got Matt Stevens from Impact Nano. He's going to tell us a little bit about their journey towards sustainable chemicals for the semiconductor industry. So welcome, Matt.
Hello, everybody. I'm honored to be able to tell you about Impact Nano and how we are manufacturing materials sustainably. Before I do that, I want to thank John Way and all the team at Applied Ventures who put this together. I also want to thank all the speakers who went before me. It's been very informative, and it's great to see the passion around sustainability in this group. And I feel that we can make a difference when we work together as we are today. So let me introduce Impact Nano to you. We're a Tier 2 advanced materials supplier. We have expertise in ligand, organometallic, silicon, and fluorine chemistry. We have 2 locations. We're located close to the Tech Valley around Albany, New York. We're in Devens, Massachusetts, and Orange, Massachusetts, where we have manufacturing. Our team has experience in the semiconductor, green energy, and pharmaceutical industries. Our company has a commitment to green chemistry and ethical sourcing. What's central to our approach is what I would call chemical fingerprint by design, coupled with ship to baseline quality. So we're thinking very much about the impurities present in the raw materials that we source and in the product that we're trying to make. And I think this is the basis for circular manufacturing. And I'm happy to follow the talk by our speaker from Inficon, because I think you saw a lot of real-time metrology data that I think can inform companies like Impact Nano in, for example, recycling materials. So that's really fantastic. So in terms of our capability, we have benchtop pilot and volume manufacturing up to 500 tons per year. And we have capabilities for safe handling of air-sensitive materials that's important for atomic layer deposition precursors, for example. Our vision as a company is to solve global challenges in computing, energy, and health collaboratively, employing green chemistry and circular manufacturing approaches. We want to be an employer of choice and a welcome member of local communities. So the overview of our capabilities are that we have the complete capabilities for safe development, scale up, and manufacturing of materials. So that includes pilot and full-scale chemical synthesis and purification, applications insight, metrology, product development capability, and also the kind of quality and supplier management expected in the semiconductor industry. We also have a strong engineering capability, which includes process development capability, scale up, design construction, and test production. So we have the capabilities to support discovery, scale up, and manufacturing. And I think that's very relevant as we try to move that linear manufacturing flow that we saw in Catherine's talk and make it into a circle. I think everybody here is pretty familiar with the trends driving demand for computer chips. It's all those things we hear about in the news: 5G communications, big data, augmented reality, autonomous driving, and so forth. And those require lots of computer chips that are made from advanced materials. And we've seen graphs that were very informative from the talks preceding mine, but just to highlight a couple items here. Even though there's been a lot of effort to try to reduce the energy use in per computation, just with the overall growth in computing, the total energy use is going up dramatically, and you can see projections from the SRC decadal plan that show that the energy use could go up 2 orders of magnitude if we don't do something about that. So that's the energy consumed in the use of devices, and then on the other hand, we have the energy consumed and the greenhouse gases that are generated during the manufacturing. And we can see from this graph from Bloomberg Green that unfortunately chip producers are overtaking the automakers as polluters. So that's clearly a long-term issue for our industry. So on the one hand, we have good progress when we look at it from a watt per computation perspective. But on the other hand, when we saw the presentation from the speaker from IMEC, we see that the energy use and the greenhouse gas emissions are increasing as we manufacture chips with more complex designs. And I've got that on the right-hand side on my next slide. So the impact of materials on semiconductors, as we said, is there can be a positive impact when it comes to the architecture to lower the watt per computation, but we do consume energy during deposition, and also many of the materials are very potent greenhouse gas emitters, very, very potent greenhouse gases. So we have a three-pronged approach to try to help with this problem, as a member of the ecosystem. So it's green company, green chemistry, and green applications. So green company is how we run our company. It starts with our mission and vision. I shared the vision with you. We are manufacturing on repurposed sites. Devens is a former military base, and we acquired a site in Orange that was previously used to make polymers. We've implemented the Sustainable Accounting Standards Board metrics for the way we run our business. And this also goes into the procedures we use for our daily conduct of our business, the priorities, how we make decisions, and also business models, how we engage with our customer base. When it comes to the materials themselves, we use the principles of green chemistry in thinking about how we want to synthesize those. And as I mentioned, that starts with thinking about the chemical fingerprint, raw materials, the synthetic route, how we're going to achieve the separation to get the purity that we need, opportunities for reuse and recovery, whether it's in our manufacturing internally, or if we can use a byproduct stream from another industry or from a fab in the manufacture of the chemical we're trying to use. And also we want to think about really the whole life cycle of our product, and that also includes what happens with our packaging and how we clean that. And then the third approach is green applications, and so there are some very practical examples, but it involves thinking about, if we're talking about, for example, deposition precursors, thinking about which impurities matter to the customer, because that can help you think about your sourcing if you're the material supplier, or it can help you think about your separation. And there are opportunities to save energy or reuse materials if you understand which impurities are important to the application. We'd like to see greener etching, and that would be using lower global warming potential fluorocarbons, for example, and there's a lot of work in the industry around that. And then I'd like to highlight a paper that was published recently by Professor Peterson, Professor Berry, and Jonas Sundquist about green CVD and ALD. Unfortunately, only a small percentage of the precursors used in deposition processes actually ends up on the wafer in the layer, and a lot of that material that is injected into the chamber ends up in the abatement system. As Catherine mentioned, there's a big opportunity there, I think, for recovering that material, reusing it, or recycling. Something that I also want to mention is that a focus on sustainability drives you to think about the many aspects, the whole supply chain, the life cycle of the product, and that also reinforces a strong safety and quality culture. They really fit right together, and so really there's an integrated approach that's possible here. Also, I'd like to say I think that there are many opportunities to reduce cost or improve business continuity in pursuing these initiatives. So I think this is definitely a win-win prospect. So just to tell you about some achievements in the first year of our existence, as I mentioned, we implemented scorecards, we repurposed an existing chemical site. We've developed a green synthesis of an important ligand that avoids the use of an alkali metal reagent that's quite hazardous. We've developed a synthesis that avoids the use of a hazardous solvent. And then we did a project in which we recovered 95% of a product that was present in the form of two isomers that were very close boilers. Those two compounds of interest were present only at a 10% level in the stream, and we were able to get 95% out of that stream and achieve greater than 99% isomeric purity for each. And so I'm pointing this out because this kind of speaks to the opportunity around recycling materials that have been used in the fab. The keys there are really to have very good metrology, real-time analysis, very good separations capability, and those are, that's the approach we have taken. So we have an analytical suite integrated with our distillation column, for example. In terms of green applications, we are tailing the synthetic routes that we use to make new materials to avoid killer impurities. We're doing that in collaboration with our partner. We're developing candidates for green or greener ALD processes with a partner. And we've been working on pilot development for a greener lithium recovery with a partner. So just to show some examples of improvement opportunities that are out there, I think that this Intel manufacturing slide has been highlighted maybe 3 times today, which just goes to show how great an example it is. And I just want to shout out to my friend Kathleen Fear, who helped push this. Intel's done a great job of trying to increase the amount of direct reuse in their manufacturing processes, and they've gone beyond what's here in 2020. So we need to do more of that. And then I just wanted to mention that this concept of CVD with real-time recycling has been around for a long time. This is from 1990, and we haven't seen it implemented yet. But something I wanted to emphasize is that with the advances in automation and metrology, I think that the time is here where this can be feasible, especially, for example, for etching. And maybe the material supplier is involved in this loop at first, or maybe this is something that could happen on site at a large user like a 3D NAND fab or something like that. And just, I think it's been said before today, but collaboration between the material suppliers, the equipment manufacturers, and the chip makers is essential to improve the sustainability of our industry. And I think that working together, we can reduce the long-term cost of ownership. So I think there are win-win opportunities here. And I also believe that by incorporating some of these concepts, we can enable new applications in this industry and others. So thanks so much for hearing about what we're doing at Impact Nano.
All right, wonderful. Thank you so much, Matt. That was a fantastic talk. So, maybe a quick question for you is, the semiconductor industry has been very performance driven, right? I can imagine, introducing new materials, new sustainable materials is not easy. So how can the industry accelerate the introduction of some of these more sustainable materials and into the or manufacturing processes, right? And also, from Impact Nano perspective, what have you seen as the biggest bottleneck in introducing these new materials?
Thanks, John. It's a great question. So, as I emphasized at the end of my talk, I think collaboration between the various stakeholders is essential to make progress here. I think when it comes to the point about, say, green chemistry, it's really about evaluating suppliers for their approach. It's about end users, for example, taking a deeper dive, making data-driven decisions. And I think that with good metrology, it's feasible to incorporate greener approaches or recycling approaches. I think, if we want to go after some of these like holy grail opportunities of taking material that's been through the fab, recovering it or recycling it, it would be really fantastic to have a testing ground. Perhaps it could be at IMEC. Perhaps it could be at Albany Nanotech. I would certainly be interested to participate where we could test this out.
Yeah.
So I would suggest that. I think one of the things I really enjoy about the semiconductor industry is that it loves grand challenges. It loves collaboration. And so let's follow some of the examples that we have with Moore's Law or EUV and put some grand challenges out there and collaborate to break through on some of these issues.
I love it. So some questions coming from the chat box. Where do you see the potential for additive device manufacturing versus traditional subtractive technologies? And is this something that Impact Nano is thinking about or planning in your roadmap?
Yeah, so I think that's a great question. I'm probably not deep enough in the technology of manufacturing chips really to be an expert on that, but certainly you could imagine that additive manufacturing should conserve the use of materials and be more targeted. I personally don't have that much experience with chip packaging, but I would think that perhaps additive approaches could work there. That's what I would suggest. Sorry, I don't happen to know more about that.
No, that's fair enough. I think it's becoming more and more challenging when you get to the higher, more advanced nodes to look at additive and also you need to consider sort of the specific materials that you're actually trying to add. There's a whole different set of a new chemistry, a new challenge that need to be resolved. So. Another question, I think, maybe around, in the earlier talk, especially in the VT panel, we talk about, hey, we should look at what are some of the new capabilities and new technologies out there that semiconductor can leverage to become more green. And one of the obvious key advancement in the last few years is AI technology. And there has been talk about AI-based R&D and chemistry development and material informatics technology. I wanted to hear your thoughts about the challenges and I guess also the advantage of utilizing AI solutions to help material developers such as yourself to develop greener chemistry or just make your operation becoming greener?
Right. Yeah. Well, I would just say that, answering that in sort of a broad way, the cost of automation has decreased tremendously. I would say also the cost of metrology has come down. And so something that's been very important to what we've done has been really to have like a smart system for purification that can get real-time feedback and adjust process parameters. So that's important because that enables you to achieve better separation, and I think that in turn enables you to do things like recycle, and we are doing some of those types of projects. I would say also that if we think again about the Holy Grail, the fabs are generating a lot of data. We saw some examples in the Inficon presentation. I think that the data coming from the real-time processing could be utilized by the recycling system, let's say, or the recycling company, if you will, to adjust parameters and make material that is suitable for reuse.
Yeah. So another question from the chat. Is it difficult to obtain CO2 inventory data for new chemicals? I guess, expand on that. When you're developing new chemicals and materials, do you have to also deal with the life cycle analysis aspect of them?
Yeah, I would say yes, it is difficult. I was really happy to see the presentation by our speaker from IMEC, and in fact, I'm planning to reach out to him. And so I would say that, kind of the approach we're taking right now is a bit more qualitative in that we're comparing routes, and a lot of what we're trying to do with green chemistry is find simpler approaches, use less solvent, for example, and in those it's pretty clear like what the benefit is. I think yes, it does get more complex if you're trying to compare two close variants of a precursor. I think it would be tricky. But I think there are a lot of opportunities out there where you don't need an in-depth analysis to see one approach is greener than the other approach. For example, if you do a synthesis that's solvent-free, sure, that's going to be better than something that has a solvent.
For sure. One last minute, I'm going to squeeze one real quick. This is again coming from the chat. What is most likely element we're going to run out of and therefore need reclaim more? Ruthenium, cobalt, hafnium, platinum, and others.
Yeah, there's a really interesting periodic table, if you Google it, that was put out by the Royal Society of Chemistry a couple years ago to celebrate a key anniversary in that, in which they sort of rank the elements, okay, by according to this issue of scarcity. Yeah. So I would recommend that you take a look at that. It depends a lot on how technology evolves. There are some surprises in that. I personally, I think that if we talk about an element like ruthenium, I think that recycling options are fairly straightforward. They haven't been implemented. They should be. And if we end up in a tight situation, they will be. So I'm not personally worried about something like ruthenium. I guess maybe some people think there's going to be a lithium shortage next year. I'm not such an expert on that, but yeah, I
think there's general appetite I see from the innovation and startup community to look at recycling and reuse of especially some of these scarce materials. And that really is definitely another part of the solution, right? Okay. All right, with that, I think we are right on time. So thank you again for the speakers. This has been a fantastic talk. And we're going to move over to the final session of the day, the closing remarks, and also announcement for the startup pitch competition.